So our next presenter is Dr. Bryan Mesmer from the University of Alabama in Huntsville. He's an associate professor in the Department of Industrial and Systems Engineering and Engineering Management. He will be presenting updates on CERC Research Thoughts ART-016 Integrated Mission Equipment Architecture Process for Vertical Lift Systems. With that, I turn it over to you, Dr. Mesmer.
Thanks, Jan. So I'm here to talk about integrated mission equipment architecture process for vertical lift systems. I'm Bryan Mesmer from the University of Alabama in Huntsville. This project is funded by the U.S. Army, CCDC, Aviation and Missile Center, and you should be able to find the slides later on if you have additional questions after the presentation. So let's go ahead and get started. So this is a larger research task, and there's lots of people involved. I'm just one of them. So I'm up there, and I'm part of the system engineering program here at UAH. We also have Kristen Vager, who's from the psychology department, Tom McDermott over at Stevens, helping us with the architecture training. We have Amy Guerin from the theater department, and we have two former DODs. We have Paul Lewis, and we have Joe Clerkin. We also have 4 graduate students currently and 3 undergraduate students. So Barbara is from the psychology program, but with a background in dance. And we have Taylor in the psychology department. We have Davey and Garrison and John, each from all different departments. So I seem industrial and system engineering, mechanical and aerospace engineering. John is from communications, helping us with tech editing. And we have Amelia and David from the systems engineering program. You'll see as we go through this presentation that this research is really highly interdisciplinary. We're really adapting and adopting approaches from multiple disciplines in order to address the key topic of this project, which is a framework for architecting systems, families of systems, and enterprise level architectures as well. So the goal of this project is to enable rapid integration of flight-capable technology in a manner that is sustainable over the life cycle of a platform, system, or component. The key words in this goal statement is rapid integration, sustainable, and the life cycle. Oftentimes in current DoD architectures, we often only think about the now and not really the life cycle, the entire life cycle. So bringing that idea of worrying about things that could happen later on into present day's decision making is critical. So what's the problem then if that's the high level goal? So we are focused on developing a comprehensive architecture. A quote from the article, Comprehensive Architecture Strategy, that this work is based off of is to a large extent, the military services develop military systems through independent procurements using a unique set of program requirements implemented by a single vendor. This creates what we call a vendor lock. We're kind of stuck with specific vendors since they're kind of helping us generate those requirements. And we really need to, at the very top level, with a system architecture, and I use system here as a very broad word, but a system architecture, be able to generate those high level needs and requirements and communicate the real desires of the DoD through that architecture. So a process then is needed to incorporate program business objectives as well as the performance, what we typically view as what the architecture contains. So what do I mean by these business objectives? So they're often captured right now, but they're captured as what we would call desirements, which is a weaker form to what we usually would have in an architecture, which is performance requirements. So what do I mean by desirements then? These are things that you typically would consider ilities: interoperability, upgradability, maintainability, affordability. All of these ilities that exist in the architecting and the systems engineering world are what are communicated, but are not requirements, or not the focus of the architectures. These desirements have some characteristics that are not always great. We're doing a study right now on affordability, working with NASA on a separate project, but related to this. And what we see in that project is a wide variety of definitions being used for affordability with no consistency, whether it's through a community or even within an organization. And that's troubling with these desirements. It creates it difficult to say, I want to improve affordability. Well, affordability might mean something different to different individuals. This could lead to inconsistencies between programs, since the definitions of how you're actually improving these utilities might be changed, and then verifying and validating become almost impossible if there's no measurement. So that's kind of where we started with this project. The objectives of the project, well, one is to assist the IME team in maturing the comprehensive architecture strategy, I'll call that CAS for now on, by researching and developing methods for consistently applying CAS across multiple programs. Specifically, we're going to employ our expertise in systems engineering theory and practice, and focusing on express preferences to guide decision-making and mathematically align contract incentives to carry this guidance across to industry. So from a academic point of view, we're really focused here on decision analysis, value modeling, utility theory, and game theory with mechanism design in there. The long-term goal is to then provide a validated and rigorous systems architecture process based on evidence. And that's going to be a key theme here as we move through the next couple of slides, based on evidence and theory from a broad collection of disciplines applied to a system of systems context. So the general task items: verify the intent of CAS, analyze CAS, make recommendations, integrate improvements to CAS and integrate it with the acquisition and engineering environment, and then transition CAS into wider usage. So we've taken these into different sub-projects, you could say, with something like the improve the transition of CAS being the development of workshops. And we'll get into those a little bit later on. So what is the main research structure here? So if we're going to create evidence and we're going to create theory and we're going to apply this and recommend certain processes to implement into CAS, then what are they going to be focused on? So what we looked at as we took a step back and we said, well, what is the main thing that's going on here from a very high level, right? From the 747 level looking down, what are we really doing here? So we started the stakeholders, and there's some elicitation task where we gather information of some sort. Those could be statements, their desires, their, I like affordability. I want affordability, or I want to reduce costs, right? They're actionable, but they're not very specific. So from there, we take those statements and desires and we do a representation process in order to form preferences. And these preferences could be in different forms. They could be in requirements, they could be in objective functions, they could be logical statements. There's a slew of different preferences and slew of different representations of the preferences. And from there, we need to communicate that out, right? So there has to be some mechanism to tell people throughout the organization that this is the preferences that we are trying to achieve. And so we need a structure, or we need incentives, especially if we're going outside of the DoD, out to industry, on driving people to make decisions consistent with the DoD, consistent with the preferences that we're communicating. And then execution. There has to be an execution process where we're actually making those decisions. So we're using this very high-level framework based on preferences, essentially, to drive our research into CAS. So now the question usually becomes, well, why are we adding all this structure to architecting? We're already doing architecting out there in the real world, and that's true. However, what we did to start off this project was that we looked at three main documents that are used in the architecting world. We looked at Meyer, we looked at Crawley, and we looked at Augustine as three main documents, and we pulled out the heuristics that are given within those documents. So architecting has very little theory to support what processes currently exist, and most of it is based on heuristics, which are just rules of thumbs. Now, heuristics can be highly evidence-based, and they can be someone thought it up off the top of their head. So we wanted to get to really investigate that, and we saw that a significant amount of those, about 250 or so heuristics that we looked at, had no evidence at all from the references that were given in the textbooks and the journal articles, which is terrifying from a perspective where we're saying, here's the process to do it, and we don't have any evidence to support that. We have case studies, which some are good, some have many issues. So we see some of the case studies are things like the number of people working on a project and they're relating it to baseball, which that could be a great case study if there's a strong relationship that's developed there, but there wasn't in that specific case. It was just this is how it's done in baseball. Look at how many people we need, and then we are applying that to architecting, and that's worrisome. And so forth. So there's really a very few that are based on evidence that would be acceptable within other engineering fields, such as mathematics. So we're pretty limited there on what the structure is. And this is why in this research project, we're really trying to produce evidence-based reasoning behind why we should be doing and applying these processes. So what are the current research activities then of this project? So we've broken it into 3 sub-projects that we're currently working on. So one is document improvements. So there's 2 main documents being generated associated with this CAS, and one is the ADM, which is the architecture derivation method, and the second is the architecture derivation process, ADP. So we're going through those documents, improving them, making sure that we're not saying too much that is not supported by evidence. So making sure that we're really concise, really focused, and clear to the practitioner. Then we're looking at the training workshop. So if we create these awesome documents and we want the industry to be applying them and DoD to be applying them, then we need to make sure that they're trained properly on how to use them. So the training workshop is first focused on a needs assessment survey to make sure that we understand the participants of the workshop. From there, we will be doing a 3-day workshop that'll be focused on getting an even playing field for architectural knowledge. And then a follow-on workshop would focus on actually looking at CAS and focusing on the processes there. So get a baseline first, make sure everyone's at the same level, and then apply or introduce the processes. And then the third sub-project here is really the main focus, which is the process framework. So here we're forming the ideal processes. We're identifying all the assumptions and the challenges. We're not going to create a perfect framework for developing architecture in this project. It's just a very big task. But we want to make sure that what we are giving, what framework we do develop, we make sure that everyone understands the assumptions and challenges so that they don't apply it incorrectly, or that they don't apply it in a way that it wasn't intended to, right? Or that they overextend it. We're going to identify recurring processes so that we can then focus on, here's a list of different elicitation processes or selection processes that we would recommend for these different situations. A big task here is the evaluation and selection of recommended processes, right? While we will have a list, we won't be able to say this is the right one for you in every single context, just because there's significantly many different contexts that are happening within the DoD. So first, let's look at each of these sub-projects. So one is the document improvements. So for the quantity, so here we're taking our advice from communication experts, and we're looking to make our contributions as informative as required, but not make our contribution more informative than is required, right? So just enough to be at that threshold. More than that, and you start to wander, and you don't understand it as well. For the quality, we want to make sure that if we do use heuristics, which at the end of the day we will be, that's what is currently being used in the systems architecting field. So we're going to have to adopt some of them, but acknowledge when we're using those heuristics and explain why they're being used and what could be done in the future if research was performed. Make sure that we're relevant, right? So make sure that the intent is being followed, and general editing, such as avoiding ambiguity and obscurity and whatnot. For the document improvements task, we have Paul Lewis, former military, working on that project, as well as John Powers, who is also former military, but working in the technical communications field. Now for the training workshop. So for this workshop, we're looking at an interdisciplinary collaboration to develop it. So here we have systems engineering, systems architecting, psychology, continuing education, and then we really kind of mix it up a bit with theater and dance. So we'll get to a second why we're bringing in those areas. The goal, though, is to make this workshop memorable and make sure that we are improving their knowledge. And so we're going to be looking at that in a few different ways. First, we're going to have that needs assessment to establish the baseline for participant knowledge. We don't want to go on a spiel for a day on things that people already know, right? We also don't want to jump 20, quote unquote, lectures ahead and hope that they can catch up. Some of the questions within the survey would be, what is the difference between architecture and architecting? Another question would be, what is the difference between architecting and designing? What I would call similar fields. They overlap for sure, but they also have their own niches as well. And by doing this, we'll enable a more targeted workshop, right? So that we know exactly where the participants currently are. We plan on doing this in 3 days, material in the morning, activities in the afternoon. And we're going to be incorporating lessons that we've done within this interdisciplinary group on previous research activities. So for example, Tom McDermott has significant experience with art-based system engineering education. We're going to be bringing that into these workshops. A previous NASA project focused on the use of improvisation to elicit preferences. So what we did on that project was we went to the Cost and Schedule Symposium within NASA, and we sat through. I'm not a cost and schedule expert. I'm a design engineer, system engineer by trade. So I went to these talks, and at the end of each of these talks, you get to the conclusion, and they would be more often than not over budget or past schedule, which seemed bad for me if that's the main metric that they're using, but the audience didn't seem to have as much concern as I did. And I'm an outsider, so this is just my views. But then what we did is at that symposium did comedy improvisation in order to understand what are the concerns within the community. So a lot of times within a community, you'll get information that's held or knowledge that's held within, and it doesn't get out. So that could be for multiple reasons. One could be they don't want people to know. Another could be that they assume people know, and so they just don't talk about it because that's an assumption that they know. And so it's hard to break through that wall sometimes. Improvisational comedy allows people to make fun of cultural norms within a community. And we saw that happen in these sketches that we did with them, these guided sketches. And you could see them making fun of the cost issues of the software. The software has significant problems on estimating the different costs and the budget, or the political nature of things where it drives certain estimates to be off from where they will end up at the end of the day. So we're bringing the concept of different methods that are used in other disciplines into these workshops to really make sure that we gather knowledge and train people in a unique way, but that it drives home the knowledge that we're looking for. Another thing that we're doing in this development of the training workshop is looking at how architecting is paralleled in other fields. And when I say architecting here, I mean systems architecting or system of systems architecting. And we see that there's a relationship with dance. So one of our graduate research assistants used to own a dance company, and she's coming in here and looking at this architecting and noticing a lot of similarities in how she views her, the way that she sketches out her dances is similar to how we have multiple views of the architecture. So we're focusing also on interpreting what we are teaching through the systems architecting training workshop here through multiple perspectives, since a lot of the architects that are going to be coming to this may not have been trained as architects initially, right? They might be mechanical engineers or electrical engineers or systems engineers, or they might be communication experts, or fields that are more technical, more hands-on, more application focused than more theory and research focused. So we really are going to be talking to a pretty broad audience here, and we want to give as many views and perspectives as we can to make sure that we get that information through to them. Again, this first workshop is focusing more on basic architectural knowledge, and then later on we'll be focusing on workshops that bring in the CAS approaches, the CAS processes. So the next steps, we're putting that survey out there. Y'all might be part of that survey. So if you do get that email, please respond. It really is going to help us out a lot, understanding who potential candidates for participating in the workshop could be. We're going to be identifying the knowledge gaps through those responses. We're going to be forming the morning material, followed by the afternoon activities. And then we're going to be developing a pre and post assessment. So it's great if we develop this workshop and everyone gives us a pat on the back, but if those participants don't get the knowledge that they need, then that was a pretty useless workshop. So we're going to make sure that we have proof that we did a good job and the workshop was successful, or we did a bad job and we need to make improvements on that workshop and follow-ons. Okay, the third research task is that process framework. So here we really need an overview framework, the 747 view of that framework to, one, improve training, and two, improve understanding. So this is both when we go to teach it and when we go to apply it. The framework will be designed to be high level and identify and link key processes that architects must perform. Before we dive into our proposed framework, I wanted to talk a little bit about definitions of key terms that not only the UAH group developed, but with the larger group that's working on this effort of CAS in general. And there's 3 or 4 different projects that are kind of going on. So I'll start from the bottom here and talk a little bit going upwards. So we have these ilities, and these ilities are going to be called quality attributes in this CAS world. And these quality attributes are really sets of quality characteristics. Now, because they're sets, they're not going to have a value by themselves. Instead, the elements within those sets are going to provide individual values. So for example, we're not going to be generating in the framework that UAH is going to be proposing, we're not going to be generating a measurement of affordability or a measurement of maintainability because of this set characteristic of the quality attribute. It provides many challenges. Another additional thing that is being worked out right now in the group is that the quality attributes can have different sets of quality characteristics. So what does that mean? So by that, maintainability could have a set of quality characteristics A, B, and C for one context, or it could have a set of quality characteristics C, D, E for a different context, right? Since DoD is very broad, if we go down certain paths to get to certain system types, that quality attribute changes in its nature. It changes in the elements that form the set, which becomes a pretty big challenge in our world of decomposing to get to a value function. So our focus then for a value-focused, decision-based world becomes on the quality characteristics. So here, these quality characteristics are the measurable factors within the set that defines a quality attribute. So these are things like the number of man hours needed for something like maintainability, things that are actually measurable that we can then use in a objective function, value function world. Then you start to ask, well, what are the dials that we can turn as architects to hone in on these measurements for the quality characteristics? It can become more difficult than the design world just because we don't have a specific implementation of the system in our minds, right? We have kind of a range of potential systems, but that doesn't mean that we can't still dial in and make decisions. So what we do is we create these mechanisms that allow us to start to define the architecture. So this is architectural decisions. This is things like what is the topology that's going to be used in this architecture, right? Is it peer-to-peer or some other different topology? And there's parameters and rules that kind of fall into this as well. But the basic understanding here is that we have these business objectives, things like reduce cost or improve the schedule, whatever it might be. We form a value function from those, and then we start decomposing. And the first level of decomposition becomes the quality characteristics. And then from there, we get down to the mechanisms. And there's tiers in between, of course, because the decomposition might go significantly further in some branches than others. But we skip past right now from the UAH proposed process of the quality attributes. So here we see the very preliminary UAH draft framework, right? So this is by no means accepted into the CAS at this point, but this is from a academic point of view, what we would propose to start with, and then we're going to be fleshing out the processes within this. So to kind of talk our way through, at the very top, we have those stakeholder concerns, and they need to be elicited, right? And that's a big challenge for any project, whether it be design engineering or systems engineering or systems architecting. Getting those concerns or that information from the different people is a massive task. And it just becomes more, in my view, it becomes more difficult as the end product becomes more and more obscure. You get more and more broad statements of affordability and interoperability, and that's great, but without those measurements for them, it becomes very challenging. You see in this framework that there's a lot of orange boxes. These orange boxes are where we need to elicit information. So it becomes very important then that we focus our efforts on understanding what are the different ways that we can do that elicitation. We need things like the stakeholder concerns at a high level, key business drivers, the context of the problem that we're dealing with, couplings, which becomes a big issue when we go to decompose. If we don't understand how the quality characteristics relate to the business drivers, that's going to be a big challenge. And when we're at an architecture level, while there is some knowledge that we can pull from prior experiences, that's going to be very context specific. So we have to be very careful on how we bring in that information. So this elicitation of information may be from stakeholders, maybe from prior projects, maybe from subject matter experts that are not the top level stakeholder. They can be from a slew of different areas, but there's an elicitation process that's required before you can really go through and make rational decisions in the appropriate places for an architecture. So once we get that information, we ask, okay, is that information enough? If not, we go back. If yes, we continue. And then we go down to selecting the quality characteristics that can address those business drivers. So what kind of quality characteristics, given this context and given business driver of reducing costs or reducing maintenance costs or whatever it might be, what are the quality characteristics that we can change to impact those business drivers? We then go into developing and understanding what are the quality attributes, what are the abilities that make sense to make sets out of these quality characteristics. And we can form requirements on those quality attributes with a focus on the measurements of the quality characteristics. We then go down to select mechanisms. Now we're forming the architecture. We have a big problem down here of evaluating the architecture. And this is something that is present in a lot of the complex engineering world of complex design engineering and systems architecting, of how do you evaluate the thing that you produce, especially since you might not see the results for 20, 30 years, especially for architecture, where we're going to have many, many different products that are produced from a single architecture at the enterprise level. How do we actually evaluate that architecture? That's an open question, right? A lot of these are open questions right now. And what we're doing is focusing first on the blue pieces and getting the framework correct. So as we move on then, there's key assumptions, there's major assumptions that we're making throughout this process framework. The first is we are assuming that there's elicitation processes that are occurring and that they result in usable information, right? We've been instructed to hold off on going too deep into the elicitation processes yet. So we're making the assumption that we are able to get that. Again, that's a significant area that needs research in efforts following this. So those elicitations include knowing the quality characteristics of business driver couplings, knowing the mechanisms of quality characteristic couplings. Essentially, being able to decompose is a key assumption that we're making, and that knowledge is available in some form for us to gather. Also, we need to be able to make sure that we understand the attribute sets, the quality attribute sets for specific contexts. So if we're dealing with a land vehicle, what are the quality characteristics that form different quality attribute sets, those abilities? The major challenges that we're facing is, well, one, what does a value model for an architecture contain, right? What must be there and what can be ignored? That's a big question. What information can we expect to elicit to aid in the forming of the value model? Right now we're assuming we can get pretty much any information we want, but that's simply not going to be the case in the real world. We're going to have to figure out what information is actually available. If attributes are sets of characteristics, then does it make sense to have attributes in a value decomposition, right? This has been an ongoing discussion within the different project groups of, can you actually measure an ability, right? Does it actually make sense to have a top level, this is the value of maintainability? My argument would be no, but there's arguments out there that oppose that. And what does improving a business concern focused value model result in if performance aspects are ignored? A driving principle behind CAST is that we focus on the business concerns, and we assume that the architecture for the performance aspects are already captured, right? But you have to understand the relationship between those two. So breaking that apart and pulling it into separate areas is a concern, and we are focusing on how do we tie that in a meaningful way so that we can make good decisions with all the information available to us. Other questions: when should a decision be deferred? How do we evaluate the goodness of an architecture? I've kind of talked about these in the past throughout this talk already. So what is the anticipated impact of this project? Well, we expect this process to transition what has been an ad hoc, heuristics-focused process that really relies on heroic designers into one that is more scientifically rigorous, repeatable, and reliable. If we can do that, we can start to prevent things like the vendor lock phenomena. We can increase the reuse, upgradability, expandability, and sustainability of developed and acquired systems if we're pushing that as key business concerns. Same thing for interoperability. If we're pushing that as a business concern, then we should result in architectures that improve that and increase the rate of innovation and number of providers in the industrial base, really focusing on the vendor lock problem. So with that, I'm out of time, but I'm happy to take any questions. And if I can't get to them during the next few minutes, please feel free to email me at brian.mesmer@uah.edu. And I'm happy to talk systems architecting with you in the CAS process.
Thank you very much, Bryan. So I think we just went a couple of minutes over for the break time right now. We have 15 minutes for break, but we do have a question on the chat session. So I understand, everyone else might have some other commitments. So if you wanted to step away, you can. But Bryan, if you wanted to address the question there by Russell. A curious question on heuristics. Reading Wrecking Systems Architecting book, there is reference on the unpublished document in Appendix A on heuristics. Were you able to get this document in your research? And he provided the link to the reference. And
yes.
For context, yeah. Okay, go ahead.
Yes, yep, we were able to get it. Yes, yeah, I think so. I think he's saying that it's available on across. Yeah, we do have that. So that's where we focused a lot of where does the evidence come from for the heuristics that are provided in Rectins. Yep.
That was very interesting. Thank you so much again for your time.
Thank you.
If anyone else wanted to connect, you can click on the attendees tab and get connected with Bryan or by his email. So thank you so much again for your time, and we'll be back for session 3 later.
Thank you.
Thank you.